We know that when we talk about alcohols, right? Alcohols are what? Alcohols are those which will be having a OH group, right? Now, what are the two ways by which we can have a alcohol? The two ways by which we can will be having alcohol is, one is called as the chemical way. We can do it via chemical way. Second is that we can go for a fermentation process, right? Or biological process, right? Please open your book. Please open your book, everybody. This is e to the power infinity. My prediction, fermentation. Definitely, right? One of the dark horses, right? In the exam paper, right? Fermentation. We do it via biological process, right? We'll be linking this to the atmospheric paper, that chapter, right? Isn't it? Fermentation. It's a biological way. How do you do that? We take any glucose source. Recent development, see, this is the winemaking industry that use this process, right? The fermentation process, right? It is many 100 years, right? This process is being done. But in the process of preparing alcohol to be used as a fuel, right? Alcohol is mixed with petrol and diesel, and 30% is used. What we take a glucose source, and this glucose source, we do what? We take it in a vat, right? We take it in a vat in a glucose source, right? Fine. Means we take anaerobic conditions. Please note down this part, right? We take anaerobic conditions, and we take the glucose source inside it, and we add yeast. What is yeast? Yeast is the biological catalyst we're using, right? And we take anaerobic conditions without oxygen. What happens? We are getting ethanol plus carbon dioxide. Now, the worst part of this, the negative part, disadvantage of this reaction is what? Can anybody tell me what the disadvantages of this reaction? What are the disadvantages? Can you tell me? Can anybody go to the chat? What is the disadvantages of this? See, who writes? Okay.
Can you repeat, sir, the
My
question?
disadvantage is what is the disadvantage of the fermentation reaction? Mhm. Okay. Okay. Good. Everybody had focused this part, right? Carbon dioxide. Okay. Let everybody come in. Right. Wonderful. Wonderful. Yeah. Good prediction. Now I'm just telling you more of it, right? The disadvantage of this process. Let me see that who has written. Anybody? Okay. Okay. Hanshika. Okay. Mokshi. Mokshi is the fastest finger, and the not the fastest finger. Mokshi has got written the right answer. Otherwise, everybody is fine. I'm telling you. Otherwise, everybody is fine, right? Mokshi and Nithila, right? Isn't it? Otherwise, everybody is fine. You all try to tell about carbon dioxide, okay, greenhouse gas. Appreciate. I really appreciate your thoughtfulness, right? That you try to think out of the box. Yes. Now, what Mokshi has written is perfect, right? Nithila, to some extent, Mokshi. See, this ethanol, right? This ethanol will be obtained 15%, right? Yield, right? 15%. Nithila has written a much more perfectionist answer. Atom economy, right? She has written, right? Okay. But in this process, we are saying what? Please try to note this down. Only 50%, 15% yield is obtained. Why? Because when 15% alcohol is formed, you can recall during the COVID times, we used hand sanitizers. They were ethanol, right? They were ethanol, they were propyl alcohols. See, it will be killing this yeast. The yeast gets killed, right? So that's a very important portion. We have to learn that. If you see that when we talk about when we talk about this process, right? It will be having a 15% yield only, right? And the reaction stops. Means there will be a mixture of unreacted glucose, ethanol, and other substances, right? Is it? So we have to go for a fractional distillation. This bit also is linked with this, right? That we have to separate them. Fraction distillation uses lots of energy, right? Is it clear to you? But this process is very important for us, right? 15% ethanol, although we get the yield, but we have to plant more trees, right? Nowadays we are using plants directly. So if we take 100 grams of this glucose or plants, we get 15 grams of this ethanol, right? Thus it helps the atmosphere also, that we are forced to grow plants, and the plants will be absorbing the carbon dioxide. Now, what are the reactions? Please open the book quickly. Page number 162. My prediction, this. And another prediction is the oxidation of alcohols, right? That part also. See, always remember that whenever we are taking alcohol, right? Whenever we are taking alcohol hydrogen is not acidic, guys. Alcohol hydrogen is not acidic. It's not acidic. But when we add a very reactive metal, right, such as sodium, when we use a very reactive metal, what happens? This hydrogen will be getting displaced, and we are getting an alkoxide, right? Isn't it? If we have taken propanol, we would have got over here sodium propoxide, right? Plus hydrogen, right? This is the way we actually would have got, right? Now, next important thing is, if we see, when we talk about, when we talk about this, right? This reaction will be very vigorous, right? And it will be giving you alkoxide. Please note down this part. Now, guys, can you just tell me, everybody, that if you take a alcohol, right? If you take a alcohol and oxidize it, right? Oxidize, right? If you take a alcohol and oxidize it, I'll be taking a break. Ethanol, right? If you take a ethanol, we'll be getting what? We're getting a ethanoic acid. And what is the oxidizing agent we are using? Please open your book, please. Acidified potassium dichromate. See, page number 163 open over here, right? Mark this as my predicted part, right? Acidified potassium dichromate, right? Is it clear? Now, we're seeing that when we see all the violet boxes, huh? Just to open, everybody open to page number, sorry, to the content number 8.1, huh? 8.1, please open. I'll be sending a video also for the 8.1. 8.1, all violet boxes will be have to be focused, right? Now come to the part of carboxylic acid, right? If you see carboxylic acid, right? Carboxylic acid will be having a acid, right? It is acid. It's a weak acid, right? It's a weak acid. What's a weak acid? A weak acid is an acid which will be dissociating much less than 100%, or which dissociates partially when dissolved in water, right? So ethanoic acid, if you take, so ethanoic acid when dissolved in water, you have to take. What's a strong acid? A strong acid which dissociates 100%, right? When dissolved in water. Again, we have to add, right? So if you take a ethanoic acid, right? If you take ethanoic acid, it will be giving what? CH3CO minus plus H plus, right? And maximum amount of the acid will be in the undissociated state, number one. Number two, there will be an equilibrium. You have to test this, right? Again, acid bases, those part. Kritik, just to do, sorry, Kailash, please grab your phone. Just to message, just to type out C5.8, C5.8, C4.9. You have to go over these chapters, right? And the reaction profiles, right? C7.3, right? These will be haunting, right? Fine. Moles chapter you have to revise. Please type out entire moles, entire C4. Right, Kailash? Entire C4. Moles go over it, right? Limiting reactant mainly, right? Write on mainly limiting reactant and gases, right? Okay. So we are seeing that in the carboxylic acid, it's a weak acid, but it will be behaving as an acid, right? That acid plus carbonate gives you salt, water, and carbon dioxide. We are getting, right, isn't it? Now, next bit is that if you see, when we go to that part of that why it is this carboxylic acid is very important. Carboxylic acid is important because we are getting an ester. What's a ester? In an ester, we are seeing that you are having the carboxylic acid and the alcohol. This hydrogen of the alcohol and the and OH group of the carboxylic acid, right? This gets eliminated as H2O, right? And we're getting a ester bond over here, right? We're getting ester bond over here, right? Isn't it? And we take a acid catalyst over here, fine. So this was all about the alcohol